Welcome back to part 2 for reverse engineering and binary exploitation, Intel x86 and x64, and for assembly part 2. And Happy New Year to everyone. I will not to be here without the incredible support of AID and the organizers. Big thanks to them for keeping me inspired and motivating me to learn and grow. And let's proceed to the topics. Okay, we continue for the assembly. For the assembly, all right, wait, try my pen. Okay, the assembly. So what is the assembly? The assembly converts your binary oh, wait, the assembly converts the binary form to the assembly language. Let's say you have executable format PE file. Okay, you want to know the source code from the file, and the way you want to know to read the file is by the assembly all right. Yes. Okay, right. And the assembly can be used to analyze and understand how software works, even if the source code is not available. Since usually software is not provided the source code publicly, so the way we can understand it by the assembly or decompiling it. All right, there's two options here, and bit represent 0 and 1. This some information, and byte represent by add bits put together, right? Add bits represent 1 byte. Okay, and from the right side you can see this is some option tools that you can use, such as this one, binary ninja, only debug, and these tools we will be using later. We will be focusing on these tools. Visual Studio, yep, can be the assembly also. For this also have some features for the compiler and have the assembly also. So it's on IDA and Jira. It depends on if you have IDA Pro, and a lot of features on there. And this one, Hue and HT editor, yeah, you can use also. This all tools is good enough to the assembly program. Okay, next. Okay, debugger overview. Okay, this we start practical. Okay, sometimes debugger wrongly interpret SDBG or wrongly interpret from hex to assembly, right? And always keep an eye also on the hex. Okay, and in this picture you can see this is a snippet from the tools SDBG. From here you can see the hex format, and from the right side is assembly format. Okay, and yeah, you need to understand the hex format also, because sometimes it's wrongly interpreted, so it's better to know and understand both. Okay, and this is a common example, like read means for written, C3, like some example, C3 to assembly, from hex to assembly. C3 push EBP is common. This one for prolog, and call EX this one for example, EAD, yeah, they have each each instruction have their own hacks, right? Need to understand that. Yeah, yeah, okay. Okay. Oh, all right. So wait here. So to see in practically. Open your debugger here. Okay. I believe in previous section you already downloaded and yeah, these tools. So let's say I take this program. This binary, yeah, you can uh, download it from previous link I already given, and you can unzip it. The password should be given later, right? Okay, but you can try. You can try also. Okay, use the password, right? The assembly. Mm, yeah, this is the the password for the zip file. Okay, you can unzip it. Once you are already unzip it, you will get this the C format program and binary program. And what you can do here is take, for example, this program and paste it in SDVG. Okay, here it's dynamic analysis. So is the output from the program. Okay, here, okay, can this is example overview on the program. This is hex and this is assembly. Next, CPU windows that show registers. There is also flex register. All right, this one focusing more on flex. You need to understand also the flex here. All right. So where is the where is the flex? This will be the flex. You need to understand like example ZF. ZF stands for zero flag, overflow flag, OF, carry flag, um, track flag, sign flag. Yeah, um, I believe it's sign flag. Yeah. And this others flag. All right, you need to understand that. So it's important also to not all of here. We'll cover this in in this lesson also, but not now. And yeah, here's the overview. Here's the flags. ZF 1 0. You need to understand. You need to understand the flags here. All right. Next, main register for S82 program. Our program is focusing more on 32 bits. So when you see the overview on the SDBG, you can see the register here. EAX, EBX, ECX, EDX, EBP, base pointer, ESP, stack pointer, ESI, source, EDI, destination, and EIP below here, right? This is registers for S32 program. Uh, Once you already good in S32 program, you want to start analyzing for debugging for S64 bit, and uh, the front here, now you should see you should see okay, you should see E here, but where this is for 32 bit. When you want to debug for x64 program, it will change to R in front of all. So let's say RAX, EBX, ECX, EDX, no, RAX, RBX, RCX, RDX, RBP, and so on. And RIP, right, will change to R for 64-bit program. Next, RAM memory debugger. So here will be the RAM debugger overview here. Right, this is all RAM, RAM dump. You can see here, right? And next, stack. Stack is temporary area in memory, store function parameter for any function call. And where you can see the stack here. Here will be the stack. Okay. In the top is stack, and in the below is raw stack. Usually, I'm focusing more on raw stack because this one good already. Right, it depends on your way to do it. Yeah, this is overview stack. Okay. Next, also, if you want to learn more about overview about debugger, you can go to this blog, right? And I will share the slide after end of all parts. So you can go to this link and learn more features or the skills features in there, right? Control flow and graphing. But we will cover this also later, these features. Next. Okay, overview for graph. All right. Graph view features for debugger that we're using. The method here, you can just right click and choose your graph, or shortcut key, you can use your G shortcut key, and you press G again to back to normal view. So when you press G, it will convert to graph mode. So way to do it practically. Let's close this one. Let's take example like jump instruction. I try this one. Okay, you can right click and go to graph mode, this one, and just click graph, and yeah, this features for the graph for SDBG. Why can I zoom zoom out and zoom in? Is that we already changed the preference and GUI mode and graph zoom mode, so it is useful for us to zoom in and zoom out from the graph. And when you press G again, we'll go back to normal. Okay, G to graph, G to normal. All right, that's features from the debugger. Next, also for view trace, this one is useful also to see what you already seen before. And the way to do it is that let's say go to tracing, thread record, and let's say I put byte here, and to step over, can click F8, 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 F8. All right. So the difference here, before this there is no highlight, and now we have tracing highlight here. So yeah, it's good features. All right, next, mnemonic brief. Right, this one also useful. The shortcut key should be, or you can right click here, and yep, this one show shift F1. Okay, that's the shortcut key. As guys can see here, there's blank here, no any information here. Once you click it, and yeah, you see, this is all things that can be helpful for your debugging and understanding the program here. Yeah, it's easy here. So yeah, this is some techniques you can use. Okay, we come to Prologue and epilogue. Let's click the screen. All right. From prologue, this one is crucial to understand, and prologue and epilogue. Okay, and most of the time, program use prologue for push EBP and push EBP to the stack, and move ESP stack pointer to base pointer here, right? And for epilogue, this one usually for leaf function. The function prologue is invalid to allocating stack space and restore the EBP value to the old one and returns control to the calling functions. And here you guys can see for the program epilogue, leave and return. But usually for some cases it depends on compiler. Uh, this one I have move ESP, move EBP to SP, pop EBP, okay, recover back, the EBP and return. Okay, this is others for yeah, the method here same, but the both one and the bottom one is the same, but it depends on compiler. All right, why they need to to make things short, leave here and return, because of they want fast, right? The leave instruction that's exactly what these two instruction do, all right? And it's used by some compiler to save code size, all right? And you want to make things faster here. That's why they are put leave and return only, right? Depends on compiler here. Prologue and epilogue also. For now, you just need to understand prologue is contain the instruction that prepare the registers and stack space for the function before it start and execution. All right. For okay, this one for prologue. And for epilogue, it contains instruction that help in restoring the stack and register to their previous state that is before the function was called. All right, this is an example before we already seen prologue. Okay, you will encounter this a lot in practical later. It will make sense when you see it in action. Right, can you go to this link and learn more about prologue and epilogue here. Right. Okay, we come to Hollow Out Lab. Okay, this will be focusing on practical. You have two options here. It's either you compile it by yourself, we quad block, GCC, and any compilers out there, or you can use the binary I already provide in this link. Okay, the template with and yeah, you can do if you want to learn more, you can compile it the binary if you want more information. And here's the password, which is when you unzip it, you can you put password with this password winter assembly. All right, this is the raw code. Yep, this is the code in the program, the source code, and this is the link that I already provided. This is the binary file, binary program that I already provided in this link. Okay, you can just download it. This is template. You can download it. All right. So it already 9:09. So let's have a break here, 5 minutes before we moving on. Right. Right. 5 minutes. 9:15. We will start again. Start for next lesson. Oops, okay, not that. Coffee. Next one. If the company show. Okay, the discussion. You can chat with me these 5 minutes. All right, and you can have a drink here. And if the company didn't show product and epilogue, we cannot. We should find it out. Should find out. Yeah, we should find it out and not modify anything because that's like a rules. Like let's say you play hide and seek, someone need to hide and someone need to seek, and when they have a rules that need to count like 10, 9, 8, 7. That's like epilogue and that's the rules for the program to start and to exit. Start rules. Yeah. Yeah. Okay. We should find it out and not modifying it. Yeah. Good. If you have any question, just drop in the chat here. In the chat. Do we need to have deep understanding on the assembly language to fully utilize the reverse engineering? Hmm. It's better to you to have foundation about it and basic because when you encounter an advanced or a long term, you will need to learn assembly and deeply understanding about it, right? And it depends also what architecture you are focusing on. Let's say one focusing more on MacBook and you can focus on ARM assembly. It's not the same the same way I teach now because for now I focusing more on Intel architectures here, right? Intel processors. There is MIPS also, and let's go back top here. You see back from previous lessons. Oh, not this one. Okay, this is some example. You can understand ARM MIPS. It depends on your depends on your target. Okay. So let's say you are reverse engineering Python program, or depends on target here. When you're dealing in malware is usually want to target Windows, right? Because the world is running Windows. Program on 32-bit program because 32-bit program can run 64-bit in operating system. So when they are developing 32-bit program, they can just drop it anyway. Still can run in 64-bit program because 64-bit program supports 32 program. 32 program here. Yeah. If you go to Explorer and if you go to Explorer folder, you can go to program files as a 32-bit program and see the application there. Right. Let's give example here. Let's see. All right, here. Program files as x86 program is what supported. This one for 64-bit architectures, operating system, and it support for 32-bit program. So usually the malware developer develop for 32-bit program to can easily drop anywhere. Okay, it's already 9:15. We continue our lessons. Our lesson will be end in at 9:35. Or okay, and there is Q&A question in the end. Okay, let's continue. Follow out lab. Here's where we left off. Here last. And I hope you guys already unzip it. All right, make sure to do this. Also, you can do this in the recording session also, because exercise is important if you want, if you want to, let's say, philosophy, let's say you want to learn to swim, but you just watch it in YouTube, you ain't learn to swim, you never learn how to swim. You need to do it practically and hands on. All right, you need to wet yourself. All right, okay, let's continue back. Hollow out lab. Okay, let's make this smaller. Okay, hollow out lab. Okay, you already um in the link Google Drive. You already download the binary template. Can just go to the program, and you should see unhollowed and hollowed program only. This all program and others program is just I will not cover this all, but it just sometimes I will need it and I will showcase to you. But for now, your link should be have this three program only. And okay, let's continue. First, let's choose unhollowed first. But if you don't want to follow the step how to unhollow it, you can just use hollowed here. All right, and take the binary and put it in SDVG. It's a x32 program. All right, how you want to identify in x82 program or what? You can go to die, and see the information there. All right, or you can go to CFF Explorer and yeah, see the program. Okay, let's go back to our SDBG. First, we know that the source code is like this. Okay, we need to go to the main function. Main function here is that we have enter an integer. You enter this is the strings, and the way to find the string is easy by doing this. You can go to search for all modules and string reference. Okay, once you go to string reference, okay, wait, yep, you go to this search for all modules and string reference, and yeah, you can see here is our strings here. Enter an integer, you entered pause in the source code we already seen before. You double click it, and here's will be our functions, our main functions here, the source code. All right, and we have push EBP. Okay, I already told before, this one for prolog and this one for epilogue. Push EB, some pushing the stack and leave and return. Okay, next, what should we do? Okay, we need to set software breakpoint at our function strings in the program. So you need to also understand software breakpoint and hardware breakpoint. How do you want to get understanding about it? Let's see, showcase here. Let's say this one. Okay, you can set. Oh, this one for software breakpoint. When you see the breakpoint here, the tab breakpoint, it show the software. Okay, for breakpoint, go to breakpoint and set hardware execution. And this one for hardware breakpoint, that's different, software and hardware breakpoint. Okay, that's we will use only software breakpoint here, right? Remove hardware. Okay, and for now, where our EIP, okay, instead EIP, you can double click in EIP and we'll showcase what we are currently at where. So when we double click it, and yeah, the EIP is in this entry point, the software entry point. We already tick unchecked for system breakpoint, so it will not go to system breakpoint. It will go to software breakpoint. Okay, software entry point. All right. How do we go to the software breakpoint? How do we go to here, the our main function here? We can click F9. F9. Okay. Can go. We can click F9. Okay. F9 for run. Okay. There's that one for shortcut key, and or you can click here. It's above that. And I prefer for shortcut key. Let's click F9 and click F9, and yep, we already, you see the EAP here. It's already in this main function. All right. Next, once you're already in your main function here, you okay. You need okay, this one for our start function and the end of our function. Right, this is the source code here. Okay. Next, hollow out, hollow up and the right function, and take note that you don't no need to hollow out all of this, because there is something that useful yeah, that will be need and useful for our right assembly later. And yeah, we need to see where the useful item, and yeah, we don't delete all of this, right? Next, okay, we need to identify where is the prologue. This is the rules that you need to follow. I mean, um, okay, the rules of the program. Functions prologue, don't delete this. Okay, this up, push EBP and move EBP, move ESP to EBP, and leave and return. Don't delete this. We need it. Okay, we need it. Next, this one. When you go to this program, okay, from here we will need a leave and useful part, example like char, to let the system system exit. All right. How do we get to know here? Well, when you see it, the program here, you click F8. F8. Okay. This is the part, something that show strings will be show up. If we call for printf functions here, is when we step over, you see here we showcase like enter and integers. All right, when we f8 again, and it will call function for scanf will ask it will ask for user to put integer in the program. Okay, for now, okay, when we step over, we'll call for input here. I cannot if I click F8 multiple times, still it cannot move. It will need user to input any integer here. So let's say I put 5. See it moving. It moving to the next step, next generation. Move something to EAX, and step over, and it will go to the call for printf function. You entered for something, which it will print you entered something. See here, nothing here. But once you step over to the call function, hmm, something happened. So let's go back. Okay, here, go here. See here, you entered some things. Yeah. Sometimes SDBG, you need to troubleshooting. I mean, you need to figure out if there is a problem happen. All right. You entered here. It will showcase printf here. You entered 10. Okay. And when we go here, we will go pochar. Pochar, these strings will be make a new line of space, F8, and wait. Okay, should be there is space here. See, now here, and there is a new line of space here, and step over again. We'll pause and jump to system, and it will exit again. Mm, see, we will exit the program. We need these two. We need space new line and exit the system. Yeah, we need it. So we left the important thing stuff here, and we will delete. We will delete. This is the code that we will follow here. All right. We will need this string space, strings new line, no new line space, and we will need call out functions here, and this is where we will call out the the program. Okay, and yep, in this one until call print. Okay, let's confirm again. ESP FF0. And yep, this is where we will hold out the function that doesn't need to be here. I mean, this is not useful for us. Okay. Next, okay, the way how we want to hold out it is by right click and go to binary here, and fill with no. It means fill with no operation here. All right. Once we click it, and we showcase this, and just click OK. See now, and this is the program now. Will fill all of if it will fill the no operation, no instruction here, no operation. Okay, this is our prologue, and this will be our epilogue and useful stuff here. That's the way you hollow out the program. Next, once we already hollow out the program, we need to patch the files because you don't want to overwrite the original program. So the way to patch it is like save the files. All right, save the what we already done doing it. Patch files. Once you click patch files, can click import and save the files. We let's say unfollow and .exe. All right, and yeah, save it. Okay. Sorry, it's not import. It's patch file should be here. Patch file and unfollow. Yes, save it. But we already have the template. We have already a template here, unhollow.exe. We just use it. Right, use it here. Okay, that's how you hollow out the program. Okay. Yep. Okay. Done. We successful hollow out the program. And this is previous that we doing unhollowed, and this is hollowed already template here. Okay. So let's use the hollowed template that already been provided. Oops, there are a lot program of running. Oh, this is some we want to identify the program. See, the file type is PE32, stands for portable execution 32-bit, and yeah, you can understand the program here. Okay, the file types and so on, the bit. All right. Okay. This is already hollowed program that we already done. Just drag and drop to the SDBG and find our stuff we already done before. Hollowed, or when you scroll down, you already see the epilogue here, and this is the no operation here. Okay, and this is the new line space and pause and leave function, and epilogue. All right, 9:31. We have 4 minutes left. So let's see the next content. Okay, fun fact also. Okay, no, when you do the stuff, when you do the stuff before that we do, and when you drop it in VirusTotal or any detection mechanism on the file behavior, it will showcase that the file is dangerous or something because you modified the program for from my side. It showcase that is have Trojan in it, and yeah, Win32 program and Trojan in it. So we manipulate the program so that the next section we will write assembly in it. That's the purpose. We write the assembly inside the debugger. All right. So this can be easier lah. Once you want to reverse engineer or something that you already practically in the debugger itself. And also it depends on compiler. Depends on compiler. Your compiler is different here. This one I'm using Visual Studio, okay, a compiler, and this one I'm using MingWO. This one MingW compiler, and they have different detection here. Right? Depends on your compiler, because compiler play a role to the binary. Okay. 9:30. We have some times left. Okay, let's okay, data storage. We will end our section at data storage size. Yeah, there is registers here, and there's a lot more. We can see here. We can useful stuff and interesting. And for now, we just learn about data storage size. Yeah. Okay, this is data storage size. Data storage size. So, okay. What is the data storage size? In 64, architecture supports a specific set of data storage size elements, all based on power of 2. Okay, here there is an example for 64 supported storage size, and C++ declaration as follows. Okay, here's the example here. So this one for byte. Byte is like I said before, at bits it represent 1 bytes. Okay, for word 16 bits. All right, for double word, this one we focusing before 32-bit program, 4 bytes, and quad word 64-bit 64-bit and 8 bytes, and double quad word for 128 bits and 16 bytes. Okay, the way easy to differentiate is my techniques also, by knowing that this one have D. If it have D is double, so it will double up the value here. All right. This one for C and C++. List of array set of memory can be reserved in any types, and any of these types. This storage size has direct correlation to variable declaration in high-level language. Right? There's C, C++, Java, and so on. And this one usually program it. This one for char character, the storage byte, 8 bits and 1 byte. Okay, there's a lot of storage here. You need to understand it. Short integer, unsigned integer, and long char integer. Yep, this is all the data storage size for C and C plus declaration here. All right, this is all the size of storage. All right, and we already in the end of the session 9:36 for part 2, and now we will start with Q&A, question and answer 9:35 until 9:46. All right, okay, Q&A question, and we start for registers for part 3. This will be the final class for the final part. All right. Wait. Okay. Okay. Q&A question. Q&A. You guys have any question to ask? Can I have a link for Hello? Okay. Wait. This is the link. Right. Wait. Okay. Okay. Go to this link. All right. And download the file. And here is the password to unzip it. Okay. Is the best way to learn is you watch for now. You just watch the lessons. Once you already figure out what you want to do, next you can watch the recording back and do it practically. Yeah, that's the best way to learn. Yeah, I sometimes mostly I implement how to the way to do it, the way to learn. For 64-bit, I don't quite understand what R8 and 15 does. Okay, that's we will not cover it because it's not common. Because wait, mm, Microsoft R8 and 15. Okay, for this one is you don't need to know now, but once you want to deep understanding more, and you can dive in here. All right. Okay, but if you want to know the details or more, you can analyze it. You can chat with me, and yeah, I will. We will talk about this. All right. It's okay. But for now, it's crucial to understand about this first. This is commonly used EAS, EBS, ECS, and yes, and until EIP. Okay. When you go to EIP, it's focusing more on exploitation stuff. Yeah. When you do want to exploitation, you need to take control of EIP. That one we will cover for the part 3. Okay. Part 3, um, as part 3, we go to TOC. This is what we already been covered so far. We already cover for the assembly, the compiler, debugger overview, this one for graph, view trace, mnemonic, prologue and epilogue, and hollow outlets, and some detection, data storage size, and yeah, we stop here. This one for part 2. Okay, this all 23 until 46 we will cover on part 3. This will be our final class, right? This is a lot of practical stuff and yeah, interesting things that I want to share about. Okay, if numbers of registers are limited, then what if the original source code have like 500 variables? Okay, you need to understand also in registers. Okay, wait, I showcase the ENS. Actually, it will cover in I'm not sure is in instruction move or maybe in fully registered and partial registered. It will cover for when you put too much number in there, and in the register will be carry out the program, and the flags will be changed because the flags, yeah, it will have carry flag. So that means let's say showcase example here. Okay, calculator. Okay, let's say hex 1 to 2 bytes 3 4. Okay, 1 2 3 4 4 bytes for 32-bit program. Let's say it increment to 1, and see this is what we call carry out. um carry out and should be the bytes 1 2 3 4 represent for 32 byte, but there is 1 here, and that's why 64-bit exists in this world to cover for this 1 bytes and so on. A lot of numbers can be controlled here. So this one 32 bits evolve to 64 bits. All right. I want to cover a lot of complex number here. I hope it answer the question here, because the same way as a question, I believe. Then what if we clear out the program? Depends on the registers, the space of the registers. Carry out. Okay. All right. We have I can take like one question again. Can be anything. Try before we end our session here. Any question left? So I guess that's all for this session for part 2. If you have any question again, you can chat with me in Linky, and we will talk more and yeah, learn some stuff. Yeah, learn some stuff. If any, okay, it's drop it question in my LinkedIn profile. All right, I guess that's all for part 2. Part 2 class, and yeah, and thank you. Cheers. All right.